This is part 3 of Modeling, Simulation and Analysis of Power-Aware Parallel Bus System. In this video, we'll make connection between parallel buses of different blocks and check connectivity using built-in check connectivity system aside tool. So let's get started. In the first step, we'll open Topology, which you can download from the link given in the description. Then open Topology Explorer 22.1 from the Cadence program menu. Select Advanced SI2 license. Then open existing design, select the topology and click over open button. In the next step, we will connect signals, power and ground nets for different blocks. Let's start with controller and controller package. So first we are going to select zoom from these buttons. Just drag and select controller and controller package. And here we can see the controller's 2 PCB pin and controller package D1 pin should be connected. To connect those, we have to first click over 2 PCB and then join it to D1 pin of controller package. Once you will do that, the connection definition window will open. So let's adjust the view here, alright. And I'm just going to, so in the connection definition window, I'm just going to short this table DQ0 to DQ15. Then we are going to select DQ0 to DQ15 by holding the shift key. And in the controller package side, we have to select DDR data 0 to DDR data 15, right click and click over connect by pin pairs. Once you will do that, here you can see DQ is connected to data 0 and similarly till DQ15 are connected to DDR data 15. We are going to disconnect VSS from here and make sure VSSQ from controller block should be connected to VSS of controller package. Next we are going to connect power pin. So let's select VDDQ from controller block and VDDIO underscore phase from controller package. Right click and click over connect. After that, we are going to connect data strobe signals. So I'm just going to do that quickly. Here we go. So after making all the connections, let's verify that we have connected all the DQ signals. Then we have connected the data strobes. Positive should be connected to positive and minus net should be connected to hash at the controller side. Then we have connected VSSQ and VDDQ. So let's close this window. Similarly, we are going to make other connections quickly. Next, we are going to connect controller package to PCB. So let's zoom in there. Select the BGA pin of controller package and connect it to U34 of PCB. Here we go. The connection definition window will open again. Make sure VSS will be connected to ground. VDDIO phase should be connected to 1.2 volt. So we have made all the connections between controller package and PCB block. Let's close this. Now we are going to connect PCB to VRM. Alright. So let's select PCB and connect it to VRM. Here we go. So here we have just two connections, 1.2 volt and ground. Make sure it is connected to power and ground. Then we are going to close it. In the next step, we are going to connect PCB to first memory package. So let's do that. So here we have connected 1 byte from the PCB side to the 1 byte at the memory package side. And then we have their DQ signals, ground and VCC. Let's close this. In the next step, we are going to connect memory package to memory. Let's do that quickly. Let's close this. Similarly, we are going to make connection between other memory package and memory. So let's do that quickly. Here we go. So as you can see, we have made all the connections between different blocks in this topology. In the next step, we are going to check connectivity between controller and memory blocks. To do that, you have to click over check connectivity link from the system SI menu and click over check button. Here we go. So as you can see, the receiver side is successfully connected to transmitter side. If you wanted to see the frequency response of these connections, you can just click over any of these. And as you can see, we have this frequency response between voltage and frequency. And as we are increasing the frequency up to thousands megahertz, we can see there is a attenuation in the voltage. But this attenuation is acceptable in our case. Similarly, you can verify with other frequency response. Now in the next step, we are going to save this topology. To do that, you have to go to topology and click over save button. In the next video, we are going to setting up timing budget and analysis option for power aware parallel bus system. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.